Question 10. We have an 8 divided by 2 to the power of 7 equals a 2 to the power of n. Now, as soon as you have an equation with a letter in the power, it's an equation with a variable or with a letter in the power, then the following strategy will work for every single one of these types. First thing you want to look at is when you've got an equation with a letter in the power is look at the bases. Look at the numbers that are underneath the power. So actually it'll be easier to underline this. We have a 2 that's here. Actually, I'll just write over it. We have a 2 that's here. We have a 2 that's here. And although there's nothing actually there, there's technically a power 1. I'm just going to highlight the fact that we have an 8 that's here. Okay? Our first step that we want to do is we want to write all bases as the same number. So we don't want that 8. We want it as 2's. Okay? And 8 is 2 cubed, which means we want to replace 8 with 2 cubed. If we do that, we'll end up with the following. 2 cubed, the other 2 won't change, over 2 to the power of 7 equals 2 to the power of n. So that just made all the bases the same. What that then allows us to do is simplify whatever we have here. Now you've got more than one option with this. You could multiply 2 to the power of 7 across. The only way I'm going to show this question in one particular way is because if this was a lot more complicated, it might just be simpler to deal with it as like one side. So just kind of focus on that as a question in itself. And the next step is basically to simplify using your laws of indices. So simplify using your laws. So what we have on the left-hand side, 2 to the power 3, divided by 2 to the power of 7, that's going to give us a 2 to the power of 3 minus 7. That's going to end up turning into 2 to the power of minus 4. So the stuff that's in blue there will give me 2 to the power of minus 4. That's me fully simplified the left-hand side. The right-hand side, there was nothing to do, so I just write whatever was there before, 2 to the power of n. Once you have wrote all the bases using the same number, and once you have fully simplified both sides using your index laws, you're going to end up with a situation that looks like this, where you're going to have 2 to the power of something on both sides, or 3 to the power of something on both sides, or maybe even 5 to the power of something on both sides. But I've never seen a question that has any other bases as powers. When you get to this stage, all you need to do is set the powers equal to each other. So we have a minus 4, we have an n, and what this does is it creates a new equation that doesn't care about these bases, which at IGCSE level or GCSE level, you haven't learned how to deal with that. So you kind of have this segue around it where it's like, well, let's just make the powers equal to each other and deal with that. Because we know that 2 to the power of something equals 2 to the power of something else. Well, the powers have to be the same because there's nothing else going on the left and right-hand side of this equation. You may be done at this point, like minus 4 equals n, which means n is minus 4. There's nothing more to do here. Or in some of the trickier ones, you might have an equation to deal with there. You might have a bit of rearranging to solve or changing the subject question or something like that. But pretty much as a golden rule, 1, if you make all the bases the same, use the same number, and the question will always be designed so this works. 2, if you simplify both sides using your index laws fully, then all you will be left to do for part 3 is make the powers equal to each other. And then I guess part 4, I put here with a question mark. Optional part 4 would be either solve or rearrange depending on what the question is afterwards. So n is minus 4, that's question 10a. Part b, we have here another equation where our letters in the power. So effectively we have the exact same thing here. Writing all the bases as the same number, well, we have 13s all over the place. There's nothing else that can be done with that. So, or in other words, they're actually already the same number. So we're good to go on that. So the first step, we didn't have to do anything. It was already done. Second step, let's fully simplify both sides. So we have something here that can be simplified first and foremost. At 13 to the power of 6, all to the power of 4. If we multiply those powers, we'll simplify that. We then have this times 13 to the power of 5 that we can simplify after that by adding these powers, which will give us a 13 to the power of minus 19. And all the while, on the right-hand side, this 13 to the power k, we didn't have anything to do with it, but once we get to this stage here, where both sides have a 13 to the power of something, we're going to make these equal to each other, and that will also have nothing left to do. K is minus 19. We are done.